Hello everyone, how are you? How's everything? I hope you're enjoying your holidays, your very long holidays actually, with your families, and all of you are safe and sound. And I also hope that you've been enjoying the online courses so far. Today, I'm gonna tell you a new subject, which is a very simple subject, but at the same time, super important. This is the basics of the microelectronics that you're about to learn. Today's subject is about diodes. Diodes are the most fundamental nonlinear components that we use in electrical circuits. Because you already know about linear components like resistor, inductor, and capacitors. Diodes are the first nonlinear component that you're going to learn about. What is a diode? Look, here, this is the shape of the diode. If you go to buy a diode from RTC from any store, they give you a component like this. In circuit, we show the diode with an arrow and a line, like this. And in reality, diode is a Pn junction. You remember when we were talking about the semiconductors, we talked about the Pn junctions. We said when we connect one p-type semiconductor and one n-type semiconductor together, we will have a p-type junction. And you remember we talked about the depletion region. It's going to be created in the middle. Again, let me remind you something else. P-type silicon or p-type any p-type semiconductor was a doped semiconductor with holes. N-type semiconductor was a doped semiconductor with electrons. That's correct. The positive side of this component, we call it anode. The negative side, we call it cathode. Why do I call it positive side and negative side? Because the operation of this component is very simple. If you connect the positive current to the anode, this device is going to work like a wire for you, like a short circuit. So it's going to pass the current with no problem. But if you connect the positive side to cathode, this device is going to work like an open circuit. It's not going to pass anything. So this is a very simple and at the same time cool device. It can pass the electricity from one direction, but it will stop the electricity from the other direction. Here you can see the operation better. When we connect the positive side to the positive current, it will pass. Look, if you want to keep it in your mind, if you want to find a way to memorize it, look, the diode itself looks like an arrow shape. So it passes the signal towards the arrow, but if you bias it in the reverse direction against the arrow, it's not going to pass it. It's going to stop it. So in one direction, if let's say here, if the I is greater than 0, it means it's going towards the arrow direction. It's working like a short circuit. If you are biasing it from the other direction, from the reverse side, it's working like an open circuit. This is called an ideal diode. Why do I call it ideal diode? Because the realistic diodes, they actually do have an activation voltage, let's call it a bias voltage. So it's not enough that you just bias it from the positive side. You need to have a certain level of the voltage, which is for silicon diodes, it's going to be 0.7 volts, or in germanium it's 0.3 volts. This voltage that you need to turn on the diode is just to overcome that depletion region that we have talked about before when we were talking about the semiconductors. But at the moment, let's not to worry about that. As far as we're concerned, in an ideal diode, if you apply the voltage from the positive side, it will pass the signal towards the arrow direction. If you apply it on the negative side, it's not going to pass. That's why it makes the diode a very good candidate to create rectifiers. Look, if you apply a sinusoidal wave to a diode in a circuit like this, only positive cycles here they can pass. So that's why your output is gonna look like this. The negative cycles are not gonna pass, because when we are in the negative cycle, it looks like you have connected the anode to the negative. So it's just gonna work like a short circuit, you see? When you are in the positive cycle, you're gonna have this circuit that where the diode is working like a wire, short circuit. In the negative cycle, your circuit is gonna look like this. It's like an open circuit. So you're gonna get 0 at the output. In the positive cycle, you're gonna get the voltage that you have over there. So this is the fundamental concept of the most fundamental nonlinear circuit component. In the next videos, I will tell you more about the applications of the diode and how we're gonna deal with the diode in our circuits. Have fun, take care, and stay tuned.